So, hello everybody, my name is Gergo and this is my first weather briefing. I work as a weather forecaster at the Hungarian Meteorological Service with about 5 years of work experience. Besides this, I am a member of the Hungarian Met Service social media team. In the last 2 years, I mainly focus on the content creation for our social media platforms, for example, Facebook, Instagram, and YouTube. If you want, you can check our social sites here, this link. So, first of all, I would like to know where are you from. Please use the tools and mark where are you. Okay. Oh, mostly in Central Europe. Okay. Oh, nice. Okay, I think everybody is ready. So, thank you, everybody. I stop the tool. Okay, first of all, let's see the current weather situation. Now you can see an infrared satellite image with the 10.8 micron channel. You can see here, and you can see the time and date, the time in UTC. I think it's a good product that you can use easily to detect clouds and synoptic scale weather system. You can use it as a first guess, and you can use it anytime. So there is a task for you. I would like to ask you to draw the weather front. Wait a moment. And yeah, so here is the question. I would like to ask you to draw the weather front and the low and the high pressure systems. Okay. Oh, nice. Oh. Oh, thank you. Thank you. I think okay. Okay, yeah. Okay, I think it's enough. Thank you. Thank you, everyone. I think it was a great job. Let's see it. So the next picture, you can see the surface pressure isobars and the Hungarian Meteorological Service front analysis. There are two big systems. One of them here is the Atlantic region, and the other one here is near the Baltic Sea in the northeast part of Europe. You can find a smaller system here near Cyprus. It's a small system, but it's a strong convective system as well. Here I would like to mention that in Hungary we used to mark with the letter A the low pressures. You can see them here, and with mark M we mark the high pressure system here. You can see it here. So what do we see? Here is a frontal zone with cold and warm fronts, and here is a big stationary structured cyclone. So let's closer look for this northeast system. There is a warm frontal cloud you can see here and here, and here is the cold frontal cloud. This cold front is moving to southeast regions, and it's getting weaker and weaker. You look at the Atlantic low pressure system. It's a big system, and Southwest Storm Naming Group issued an orange warning here, and called it or named it Armand. So this system has a name as well. You can see a big area with no clouds. So here high pressure system, we call it anticyclone. Okay, I think it's enough for this picture. You can see here the air mass satellite image. We mainly use this type of product to detect the air masses and the cyclogenesis, and it separates clouds of the different levels. In this case, the dry stratospheric air behind the cold front is easily to detect. You can see it here. And you can see the tropical warm air here as well. So the dry stratospheric air will move to the southeast and bring some cold air here at the east part of Europe. And here in the middle of the Europe, the warm or mild air is the dominant. In these areas, the temperature is higher than the average. For example, some areas, the temperatures were very close to 13 degrees. For example, south parts of Spain. So you can use this product to detect the jet stream. In the next picture, you can see the jet streams. You can see here and here, and here in the big low pressure system. In the Atlantic region, there is a big system. This system heading to the east, and it brings some thunderstorms for here, for the west part of Spain. Later, it will move to the east part of the country and the west part of France. I think it's a very nice and complex structure. So you can see here the next image. You can see here the microphysics RGB. With this product, we easily do a cloud analysis, estimate the thickness of the clouds, and separate the ice and the water clouds. You can see the frontal system. It is a weak system, so there is some thick clouds here. And in the Atlantic region, there are various cloud systems. You can see here a lot of convective activity, so there are thunderstorms as well. This product is used to detect the foggy areas. So you can see here some foggy areas. In the next picture, you can see them. So here are the foggy areas, and you can see here the thunderstorms. You can see here some rain, and you can see there some light rain as well. So I think it's a typical weather situation for the country. So in this picture you can see the natural RGB picture and radar images. You can see here are a big area that some light and heavy rain. You can see here some rain areas and here too. And you can see the weak cold front with some precipitation. It's something like light rain or something like that. And here some thunderstorms as well. So let's see some forecasted charts. Here is the 500 geopotential charts. So we can see two big low pressure systems. First one is here, the second one is here, and in the middle of Europe there is a ridge. At the lower levels you can see a big temperature contracts in the middle of Europe. So in the ridge, the air is mild or warm, so there is a big positive temperature anomaly. For example, in the west part of France and the east side of Spain. So I think it's a typical weather situation. So you can see here the cold air. The cold air is will be moving to south and the southeast, and it reached Hungary today, but it will be colder the next few days. And as I mentioned, you can see here the big positive anomaly for a big temperature. It's a forecasted chance. So you can see here it will be warmer than the average. So thanks for your attention, and I give the staff to Andras.
Thank you, Gergo. Welcome, everybody. Good afternoon. I will continue this weather briefing with a study case. But first of all, some information about me. My name is Andras Vaszko. I graduated in July 2018 with a Master of Science degree at the Eötvös Loránd University. I've been working in the Hungarian Meteorological Service since February 2018 as a severe weather forecaster, but I also perform tasks in general forecasting, for example, short and middle range forecasting. Furthermore, I'm a member of the social media team of this service too, as Gergo. And as Gergo, this is my first weather briefing. So I brought a very interesting study case from 29th of September, focusing on Central Europe and Hungary. Maybe that is a memorable weather situation for some colleagues of Central Europe. At first, this is an RGB air message from 29th of September 0 UTC. And now let's play again. But here the questions are not the same as in the current weather situation. My question is that where are the jet streams in this picture? I think you can draw it. Yes, I can see. Yes. Nice. Okay. Now let's check it. So you can see in this image well-defined strong jet stream on high levels, exactly 300 hectopascal. I try to show it to you. So this is the strong jet stream from the North Atlantic across Ireland and Spain and Italy to Southeast Europe. And this jet stream draws out for us a long way trough. And this trough, we can see this trough in this page. In this image, I would like to show this long wave deep trough, and this trough reached down to North Africa, and Central Europe with the Carpathian Basin, Hungary, was located in the front side of this trough, and this trough covered the northwest half of the continent. It was a very large. It was a very large and a very deep trough. So now we can see in this picture the geopotential distribution with the equipotential temperature and the wind field at the level of 850 hectopascal. In this level, we can analyze an extensive low pressure system. I would like to show that system. This is the extensive low pressure system, and this system has more center points, and in Hungary these points were marked with the letter A, as Gergo mentioned. And you can see long frontal zone, long waving frontal zone, and this frontal zone belongs to this low pressure system. And in this frontal zone, there was classical cyclogenesis on the over North Italy, on the south side of the Alps, and the southeast side of this low pressure system, warm, humid air advected from the Mediterranean Sea, while in the cold, dry air progressed to the southern parts of the continent on the northwest parts of Europe. This weather situation favored cloudy weather, high precipitation, indeed thunderstorms and supercells too in some places in the Central Europe and in the Carpathian Basin and in the Mediterranean Sea. You can see in this infrared satellite image some extensive cloud array with low temperature of cloud tops. I would like to show them to you. For example, this cloud top is less than about minus 55 Celsius, but it was
sorry, Andras, I cannot see what you're pointing to, so please, can you just take a highlighter or a pointer? And
2 seconds, it was a technical problem. So now,
yes, I can see your mouse.
Okay, I think it's good now. So, for example, this cloud top was less than about minus 55 Celsius, and it was, for example, an extensive cloud zone with about less than minus 55 Celsius. And on this day, this weather situation causes big differences in Hungary between west, northwest, and the east, southeast parts in this country. For example, on the west, I would like to show. On the west, the maximum temperature was only about 14-15 degrees because of the closed cloud cover and persistent rain. However, on the southeast countryside, the cloud cover was fragmented, scattered, and the advected air mass from southwest was much warmer. Because of these factors, the maximum temperature was about 8-10 degrees higher these countrysides than the west parts, as you can see. It was a rainy day almost in the whole country. There was an extensive rainy area at southwest northeast axis. I hope you can see. It was a rainy day, and I hope you can see in this precipitation map an extensive axis, southwest northeast axis, from the southwest boundaries across the Lake Balaton, across our capital city Budapest, to the northern mountains. We measured the higher precipitation values in this axis because extensive precipitation zone passed through this axis with persistent rain from southwest to northeast. On the south and east parts of this country, as I mentioned in the temperature map, the cloud cover was scattered, the sun was shining for a few hours, the temperature was higher than west parts, so the unstable energy could increase in this advected warm humid air mass, and because of these factors, heavy showers, thunderstorms could develop with locally high precipitation values, as you can see. And these storms caused locally large hail and harmful wind gusts. These are the strong wind gusts. As you can see, the strongest wind gust as we measured was 76 kilometers per hour in this map. Okay. So I mentioned that thunderstorms, strong thunderstorms could develop, and supercells could develop too. There were some supercells, and you can see the strongest one in this picture near to West Szeged. And this supercell was formed near the south boundaries, and this caused the most damage in our country, mainly the large hail and harmful wind gusts. I want to tell you that our colleague on shift did a very good job, because as you can see in the alarm map, she issued level 2 with appropriate time advantage. You can see the level 2 with orange color, and in Hungary, in case of thunderstorms, we issued level 2 alarm, orange alarm, if the hail diameter may larger than 2 centimeters and the strongest wind gusts may exceed the 90 kilometers per hour. We got from this day some very spectacular photos from some cities of this supercell. I mentioned that the strongest supercell on the previous radar picture was near to Szeged, and you can see 3 very very good pictures from Szeged. You can see the very interesting structure of this supercell. I hope you can see as I show. And this is the same supercell over Baja, and you can see these pictures, the damage of the large hail, about 2-3 centimeters. It wasn't a friendly weather in at the end of September, and it's a very funny and very absurd thing in Hungary that the September was the most convective month in Hungary in this season. So it was our first weather briefing. We hope it was useful to you. So thank you for your attention. Thank you very much.